Hello everyone. One of the questions I get asked quite often by students is how to balance simple chemical equations. So in this video, this very short video, just want to explain a few simple procedures to follow when you're looking at balancing equations. To start with, I just want to highlight very simple principle using hydrogen. Now hydrogen, like oxygen, travels around as a pair of atoms, and the chemical symbol for hydrogen is H, and because it's a pair, we have H2. A little number 2 goes to the side. Now that, if I were to draw it as actual physical atoms, if we imagine we have one hydrogen here and another hydrogen here. So the two go around together, the two hydrogen atoms go around together. Now H2 is very different to 2H. 2H could be that we have one hydrogen atom here and one just randomly over here. They're not together, but we still physically have two hydrogen atoms. So in the top one we have number 1, 2 here, and in this bottom we have 1, 2. So on the bottom one, the 2H just refers to having two lots of the hydrogen atoms, but in total we still have 2 and 2. But where the number goes is really important. Let's take, for example, and if we just shrink the screen and turn that up a little bit. Let's take, for example, CO2. Now that's a symbol for carbon dioxide. Di meaning two, oxide, two oxygens, carbon dioxide. Now, if we had, for example, 2 lots of CO2, then what we have is 2 lots of everything that the 2 is in front of. So we can put brackets around like this. That would mean that we have 2 carbon atoms, 2 of the letter C, and we have 2 lots of O2. So if O2, 2 little oxygen atoms here, and we have 2 lots, then in total we have 4. So in 2CO2 we have 2 carbon atoms and a total of 4 oxygens. Okay, now we're going to use that basic principle to balance a very simple equation. So again, we'll keep this at the top corner here just so we can refer back to it. Let's take this very straightforward equation. We'll write the word equation first. Magnesium plus oxygen gives, and anytime a metal burns in oxygen, it forms a metal oxide. So in this case, we're going to form magnesium oxide. Now if we do the symbols, the symbol equation for this reaction, what we'd have is Mg, the symbol of magnesium, plus an oxygen travels around as O2, goes to, now magnesium oxide has a symbol of MgO. When it comes to balancing equation, really straightforward. You just imagine that there is an imaginary line going down the middle over that arrow, and you just count the letters. You have to have the same number of letters on the left side as you do on the right. So let's take the Mg, the magnesium. On the left side, on the left, we can see we've got 1 lot of magnesium, and on the right side we can see we've got 1 lot of magnesium, so they're balanced. On the left side here we have O2, so we have 2 oxygens, but on the right side we only have 1. Now usually when you balance equations you try and multiply up the smaller of the numbers to try and match the other side. So ideally we need another oxygen, so if we had 2 oxygens that would be perfect. Now you'd think you'd put a little 2 after the MgO like so, MgO2. But you can't do that. You can't magically just make an atom just pair with another atom, like we had at the top here with H2. It is a pair, and you can't change the number after. If it's a pair, it's a pair. But what you can have are multiple lots of it. So if we just go back a few steps and get rid of our 2 here, and instead put the 2 in front of the whole thing, 2 MgO, we now have 2 oxygens because we have 2 lots of everything in the bracket. So now we have 2 oxygens, and our oxygens are balanced. But usually when you're doing balancing equations, when you change one thing, you always seem to change another. And now look, what we have done is double our amount of magnesium. We now have 2 lots of Mg. So if we go back over to our left side, we only have 1 lot of Mg, magnesium. So again, I could put a 2 there, but remember what I said, you can't magically make the magnesium pair with another, but you can have 2 lots. So if we'll delete the 2 there, and instead if we put a 2 in front of the magnesium, then we have fully balanced this equation. Let's move this up and let's draw this as a few circles, and it should be really clear to see. So on the left hand side now, we have 2 magnesiums. I'll draw those as atoms. And on the right hand side, again, 2 magnesiums. On the left hand side, we have 2 oxygens that are paired. And on the right hand side, we have 2 lots of oxygen. So 1 oxygen atom here, 1 over here. Now it doesn't matter whether they're paired or not. Like I said, we just have to physically have the same number. 2 magnesiums on both sides, 2 oxygens on both sides, and that's it. We have balanced that equation. So let's try another example, another basic example. We'll shrink the screen and we'll maybe keep this one up just as something to refer to. Let's try another metal with oxygen, quite simply. Sodium plus oxygen gives sodium oxide. Once again, got 1 sodium on the left, sodium on the right, 2 oxygens on the left, 1 on the right. So if we double our right hand side, we now have our 2 oxygens. But we've now got 2 sodiums, so we need to provide 2 on the left hand side to make that balance. Now that's a fairly simple equation, so what we're going to do now is got a little bit more advanced. We're going to try a little bit of a trickier one and see if we can do that. So let's move everything away here. Let's take this equation here. CuO, which is copper oxide, Cu is copper and O is oxide, reacting with HCl, which is hydrochloric acid, and they form, when reacted together, copper chloride, which is Cu, Cl2, and water, which is H2O. So copper oxide and hydrochloric acid will give copper chloride and water. Now, even if you're unsure of what all the symbol means, if we just follow the same pattern, we can balance this equation and make sure all the letters, all the elements are equal on both sides. If we draw the imaginary line, in this example we have 1 atom of copper on the left, 1 copper on the right. We have 1 oxygen on the left side completely, and left side being this whole region here. And we have 1 oxygen right at the end here over on the right. On the left hand side we have 1 hydrogen, but on the right here we have 2. So we need to do something on the left hand side, and if we double the number of hydrogens, it will balance. Now we can't, like I said, you can't just put a number 2 here. You can't just pair up an atom. But what we could do, if we get rid of the number 2, is just imagine we have 2 lots of that. So if we put a number 2 here on the left hand side, what that means is now we have 2 lots of HCl. So let's look at our hydrogens again. We have 2 hydrogens on the left and 2 on the right, so that's now balanced. But what we've managed to do also is balance the chlorine, because now here on the left we have 2 lots of Cl. So that's as if we have a chlorine atom here next to chlorine atom here. Again, not paired, we just have 2 of them. And on this right hand side we have 2 chlorine atoms together, paired up. So there is our balanced equation. All we have to do is put the number 2 in front of the HCl, and we've balanced it all. Now with balancing equations, all you're trying to do is just make the same number of atoms on the left and right hand side, just for the sake of argument. But it's essential that you know your chemical symbols. So you would need to know that Cu is copper, O is oxygen, H is hydrogen, Cl is chlorine, for example. So, I hope that helps. Thank you.